Small-scale producers can maintain optimal field fresh quality by introducing simple methods for cooling produce and maintaining appropriate relative humidity levels to reduce post-harvest losses. One significant factor in extending product quality and shelf life is maintaining temperature control from harvest to consumption. Once fruits and vegetables are harvested, they are no longer attached to the root system, but they are still living. Therefore, any water that is lost can no longer be replaced through the roots. Lowering the temperature as quickly as possible after harvest will slow down the rate of living and extend the product's shelf life. There are several simple practices useful for maintaining the shelf life of produce, such as harvesting early in the morning during cool ambient temperatures, using shade tents, and adding fans to assist in circulating the air. Room cooling can be achieved in an insulated storage room which is refrigerated or with the addition of a CoolBot installed on a window unit air conditioner. Forced air cooling is much faster than room cooling alone. The simple addition of a household window fan and a curtain draped over the produce can be very effective. The most effective cooling would be combining room cooling with forced air for products that are not chill sensitive, such as cauliflower. A trimmed single head of cauliflower with an internal temperature of about 92 degrees will cool with these methods at the following rates. Refrigerated room with no forced air, about 5.5 hours. Forced air cooling, about 1.5 hours, compared to hydrocooling, about 7 minutes. Hydrocooling provides a fast, uniform method for cooling some crops such as leafy greens and summer squash. The simplest version of a hydrocooler is a tank of cold water and food-grade sanitizer in which produce is immersed. For tomatoes, it is important to note that water temperature must be 10 degrees Fahrenheit warmer than the internal temperature of the product to prevent water permeating the product. Otherwise, the shelf life is reduced. Once produce is detached from the growing plant, it continues to transpire and lose water. To minimize water loss, maintain high relative humidity in storage throughout the distribution chain. By the nature of cooling, refrigeration systems have a drying effect on ambient room air. Humidification systems and practices can help to maintain relative humidities of 85% or higher for fresh produce. Devices and instruments are available to monitor temperature and relative humidity. Here are some common North Carolina grown products with some general guidelines on optimal temperatures for storing fresh produce and expected shelf life. Customers may specify the temperature at which they require produce items to be delivered, which may differ from the temperatures listed in our guidelines. Compliance with customer specifications is important. Fresh fruits and vegetables are unique packages of water, each with their specific temperature and relative humidity requirements to reduce the respiration and slow down the metabolic process, the rate of living. Remember that even short exposures to extreme heat or cold temperatures can result in a decreased shelf life and loss of quality. Maintaining the cold chain, including optimal storage conditions throughout the supply chain, is needed for optimal shelf life and maintenance of the quality of harvested fruits and vegetables. The symptoms of physical injury do not usually appear until the buyer or end users observe these defects as poor quality further down the supply chain. For product-specific guidance on temperature and humidity management, visit the North Carolina Growing Together website. The Wholesale and Retail Product Specification Manual is available as a resource.